So before starting the NumPy, let's give you a quick review of everything. So we have learned the basic types. You learn, right? So you know the container types, the identifiers, the conversions, the variable assignments. All right. So you know these things. The sequence, container indexing, or normal indexing methods, right? The Boolean logic, the statements, the if-else, or the modules of Python, like kind of import maths and all those things. SciPy has been done. So these are the basic things, right? So I think you have done this. Next we got the normal things, kind of condition loops, iterative display, input output, how to take inputs and all, integer sequences, function definition, operations on the list and all those things, list and tuples. I think you have done these things, right? So not getting much into those things. So I'll send you these things for how it works, try and accept and all these things, right? Okay, so today we are learning the NumPy. So you can see, let's get started with the NumPy one. Okay, so NumPy is a Python package that stands for numerical Python. Okay, it is a Python package which stands for numerical Python, and yes, so it is used for the scientific computing or in the powerful n-dimensional array objects. Okay, so if I write the definition of a NumPy, what I'll write it. NumPy is a Python package that stands for numerical Python. Okay, that stands for numerical Python. Just the core library for the scientific computing, which contains a powerful n-dimensional array object. This is what NumPy standard definition is. Okay. Now the question comes that why we use NumPy, why or where the NumPy is used. Okay. So Python NumPy arrays provide tools for integrating C, C++, JS node, etc. Right. So it is also useful in the kind of we have read till now, the kind of linear algebra, random numbers capability, and all those things. Right. So NumPy array can be used to store an efficient multi-dimensional container for generic data. Now let me tell you that what exactly is a Python NumPy array. Okay. So okay, if I write it as where it is used. So where is Numpy used? So where it is used? So as I say, this Python Numpy arrays provide let's say tools for C, C++. Wait, yeah, just miss it. So it is used in the linear algebra, the random number probability, right? So this can be used in these sections. These are the spaces where these are used mostly. Okay. Now, okay, these is where NumPy are used. Okay. Now, what is Python NumPy array? That is a powerful n-dimensional object. Okay. So this is what is NumPy? This is NumPy. This is NumPy, right? Let's try to see what is NumPy array. Okay. So we can just write np array. It is NumPy array. It is powerful. Okay. It's a kind of, as I said again, that is an n-dimensional array. So it is a powerful n-dimensional array object which is in the form of the rows and the columns. Now we can initialize these rows and columns as kind of nested list, and we can just work in that. Okay, so these are the np array. Okay, so installation is very easy of this. If someone is installing in the, let it be someone is working in the PyCharm, so installation is very easy. You can just write on pip install numpy and that's all. So how to start? Let's see. Okay, so we start with the term called as dimensions, single dimensions, double dimensions, more than one dimensions. Okay, so what are dimensions exactly? If I say, so what are dimensions? You can say it's kind of the axis you are getting, that is x, y, z, and all these, right? So that can you say that these are in my dimensions, right? Okay. Now let me say you that if I want to build a single dimension numpy array, single dimension numpy array. Like I'm just writing like this. Okay, this is what I want to write now. One second. Terminologies, NDA objects. So for a single dimension, what I need to focus is the number of, let me zoom. Anytime the array when you start working in the array, the main thing you need to focus is the brackets. How many brackets are there? Don't count the brackets. Count, let's say you are writing something. Let's say this is a kind of a numpy array I have. Okay. Just consider this, that don't go for the logic now. So what you see that the first number you can see here, right? So the first number you can see here. The number of brackets you can see is the number of dimensions this array is having. Okay. Understood? So number of dimensions you can see is the number of brackets is starting. Similarly, there is some errors in the number of brackets ending up. So you can see that this is starting with the, one second, this is wrong. Yeah, correct. So you can see it's starting with the number of two brackets. Okay. So there are two brackets. So we can just say on that this is a two-dimension Numpy array. Okay, so you can call it a two-dimension. So what would be a single dimension? This could be a single dimension array. Only one brackets and one dimension. So if I say that, if I write it something like and now can I say that this is a three-dimension? I can say, right? Because it is starting with three of the brackets and ending with three of the brackets. So we can say that this is a three-dimension. Okay. Now before going to the dimensions, let me say you that whenever you will be writing a NumPy array or anything, so you will be getting an n-dimension array. That could be an n-dimension. Now NumPy states that it's working with a dimensional array. So this is called as an ND array, right? So if I write it as for the single, let me just state you that most important object that you define in NumPy. The most important thing that you define in NumPy is your n-dimensional arrays. It is most of the important thing to focus on. Okay. And this is itself, and this is called as your ND array. This itself is called as the ND array. So it describes the collection of items at the same time. Okay. Someone has came. So this describes the number, or you can say the collection data type. Now what is this D type? Okay, so we'll see what is this D type. It's nothing but your data type. Now for the data type, you will write it as that every item okay, so every item in an ND array takes the same size of the it's the same size of, you can call it as a block in the memory. Okay, depends on you what you call it. Okay, so each of these elements, every item or the element is of some data type. Okay, so each of them has a particular data type. That is called as D type. Alright, that is only the D type statement. So this is your D type, and these are the n-dimensional arrays. Okay. So the basic ND array is created using the function called as ND. So first of all, you have to import this. It depends on you how you import. I import it as NP. So first thing is to import the Numpy as the NP. Alright. Now, as I said that the basic ND array is created using the array function. How? That is np dot array. That's all. So this is a function of a NP array. Now this creates an ND array from any object exposing to any array interface. Okay, so this particular thing will give you, so this will give you a syntax as np dot array, and you have your object there, what you are defining. You have a data type of that object, whatever you are writing, so that can be anything. There is a copy, and also there is order, and okay, let me write it as data. So these are the syntax particularly. So data type you are having, so data type can be anything. For by default it's none, and you're defining the things, then it comes there. So copy by default is none. You can check it by just writing as np dot and array, and you will get everything there. If I just remove this, so it says that you have these things. There is array, object, data type none, true copy to true, order k, and what are these things? So it particularly creates an array. Object is an array, any object exposing the array interface. Data type is an optional, you can write or not, it depends on you, as I said. So desired data type, then you have to copy. If true, then the object is copied, otherwise a copy will only be made if array returns a copy. Okay. Order of KACF is optional, specifies the memory layout. If the object is not an array, the newly created array will be the C order, row major, unless F is specified, and these are the things you can just see on, right? So K is equals to unchanged, no copy, F and C preserved, and all of these things. Okay. So there are many things. We'll see the endim. Endim is the number of dimensions, and you can just have a look on all these things. 0, 1s, empty like, and these things, right? So a basic definition of an numpy is there itself in the NP. Okay. Moving on, we'll see how to define. So you have seen, right, what are the things there. So object will say you if any object exposing to the array interface. D type will give you the desired data type of an array, and it's an optional method. A copy will by default is an option also. So copy will give you the object if you are just copying anything. Okay, these are the things you will have it there. So let's make it a basic numpy array, the first numpy array. So np dot array, and let's write it as 1, 2, 3, and before that let me give, okay, let it be there. So it's np dot array. That's not. This is your array, and let's store it in A1. So this is my first array, np dot array of these things, and then just I'll be just printing on the A1. That's all. So you can see it's 1, 2, 3. Now for checking the dimensions, what I'll do? For checking the dimensions, I have something called as n dimensions, right? So I'll go it later onwards. So this is a single dimension array, right? Okay. Similarly, there can be a multi-dimension array. So only these two kinds of array exist there, right? So we have single dimension array, we have multi-dimensions array. So single dimension array we saw, for more than one dimension is called as your multi-dimensions. Very easy. So let's say it's A2 and this is np dot array. Let's say this to be 1, 2, 3, 4, 5, 6. Okay, that's it. Let's print out the A2. Okay, let's print the A2. So this is 1, 2, 3, 4, and 5, 6. Okay, I'll make you understand what are you getting here. Okay, so these are your dimensions, right? Now, what I'm saying that if I want to see the number of dimensions I have been making out. So for checking the number of dimensions, so to check the number of dimension of an array, we use ending. Okay, what we use is ending. That states the number of dimensions we are having. So let's print it off that the number of dimension. 1 second, guys. Yeah, so let's say the number of dimension of A1, right? So number of dimensions of A1 is, what is the number of dimensions there? Let's say this is to be format, and A2 is this. Let's take both at once. So format would be A1 dot n dimensions, and this will be A2 dot n dimensions. Okay. Format A1 and the number of dimensions of A1 and A2 respectively, and let it be. So you'll be getting that A1 number of dimensions is 1 and A2 is 2, right? That is a ndim use. Okay, so it's properly A1 dot ndim and it's A2 dot ndim. This will give you, that is, number of dimensions you are having in your arrays. Alright, moving on. Now let's say you want to define an array and you want to give the number of dimensions according to you. Okay, you want to give the number of dimensions now according to you. So what you will do, okay, what you will do is you will be applying some dimensions use. You'll be applying some dimensions use. As I said that when you write np.array, when you write it and when you check it over there, you will see ndmin. So when you want to define minimum number of dimensions you need, okay, so we'll be doing one by one every of these parameters. So when you want to define the number of minimum dimensions you need, so you will be using ndmin. Okay, so what you will be using there, that is ndmin. So it says that the number of dimensions you are using. Okay, so we will write now for the minimum dimensions. Oh, so for the minimum number of dimensions. to set the minimum number of dimensions, we use NDMIN. Understood? So we'll be using this to set the minimum number of dimensions of an array. Alright, so this I'll be writing it as, let's say I'm making an array A3, and this is an Numpy array, and the numbers are 1, 2, 3, 4, 5. Right? And I want these, not, you can see that it is a one dimension array, but I want these to be the n minimum dimensions to be 3. So I want it to be 3, and I'm giving it as a kind of one particular dimension. So we'll see how we get the output. So when we print our A3, we'll see these as a kind of starting with 3 of the brackets, right? It states that this is an 3-dimension array. Okay. You can check on for the size of the A3, that is A3 dot, not size, dimensions. So it is a 3-dimension array now. Alright, fine. So this is how you can just give the minimum dimensions and then you can work on. Right. Now you can define the data type too. Okay. Now to set the data type of a particular array, we use dtype alright. So we'll be using this, the dtype one. So let's say now this is an array 4, okay, and this is NP array. Numbers, let it be 12, 13, 14. Number of minimum dimensions, let it be 2. Okay, and let's now give the data type 2. So we can fix our data type to anything. You can write it as a kind of a Boolean function. You can write it as a kind of a complex type. You can give it as an integer. You can give it as a float. Depends on you. Alright. So let's take it as a kind of Boolean, and let's see the printing of the A4. So when I see A4, what I'll be giving the true results. Okay. So every number it's itself for a true. So I'll be getting like that. Okay. Instead of that, if I have done in the A5, if I would have written the same as this. It's a space is there. If I would have written as a kind of complex or any other data type. So I'm defining this as a kind of a complex. So we'll see it's printing. We found it to be 12.0.j, 13.0.j, and 14.0.j, because we find everything inside the complex number to be as a, by default it's a kind of a float there, right? So we see the dtype parameter also. This is how it works. Okay, moving on to next. Now as I said, you can define your data types. So there are a lot of data types to define for you. Okay, we have studied some of them, I think. Right, kind of things. Let's say you are taking for the bool, so bool will be for the boolean. Integer for will be for the integer value, right? So let me define it as one by one. So let's say data type. So you want the data types now. So data types could be a set. Let's say you want it's a bool. So bool will be having value of true or false. You will be getting, right? So these are stored in a byte. Alright, these are stored in a byte. Let's say this is a bool and this is the value. Alright, let's give is 1. Okay, this is the value. Similarly, let's give the data type 2. Let's say this is integer. Okay, so I'm not going to write every of the definition. So integer will by default it will make you a integer value. Let's write the next. So seems there is a float. So int c, particularly if you write int c, this int c. So this is normally a integer of 32-bit or integer of 64-bit. Okay, normally a 64 or a 32-bit integer. Similarly, you have int p, int 8, int 16, and a lot of things are there, right? Float 16 and all those things similarly. So let's say these are my some of the types I have written. Arrays must be of same length. So you can see the first class kind of a class boolean, class integer, and all these things, right? So just make it look simple. So we have boolean class, integer class, float class, complex class, 64, 32-bit. I'll be dealing with what I have done here. Okay, this is not for you for now. Let's go much. No, don't go much into these. Let's focus on our Numpy. Okay, so you have object, you have the align category, and you have the scalar category too. So as I said, if you write working with the, let's say I'm working with now. So working with some D types. So you'll understand how the data types are. So let's say I'm saying data type 1 and this is a kind of a numpy array. Now this is a kind of a numpy array and I'm storing this as integer of 32. Okay, so I'm having an array, let it be 1, 2, 3. There I'm saying my data type to be np of integer 32. If you run this, if you just see on, or if you just print on dt1, so you'll find that this is kind of this, right? But instead of printing this, if you just similarly just print on dt1, you will get that it is an array of 1, 2, 3, and the data type is integer of 32 bits. Okay, depends how you define it. Let's say you have defined the same thing. Let's make a copy of this array. So the copy is very similar. D2 equals to D1 copy. That's it. Okay. Fine. This is now I am saying that D2 is the D2 data type is np dot integer of 64. I have done this. I have seen this one. So when I print D2, I'll see that it's a kind of an integer 64 type. Okay. So for checking data type of any particular thing, what you have to do is just write the array name. Let's say A2 is we have. So A2 data type is integer of 64. Okay. So you can check any data type by this, right? You can define your integers. So if I also write that np dot d type of, let's say, I4. So this also states that it's a data type of integer 32-bit. Okay, these are the normal things. Okay, so integer of 8, 16, I mean to say that integer of 8, int 8, int 16, these are the bytes especially. So integer of 8, integer of 16, int particularly. So it's 32 or let it be 64. So these are can be, you can write. So these can be replaced by I4, I2, it's I4, I1, I2. Yeah, you can say it's I21. You can say I2. This 32 as I4, and this is I6. So this can be just taken out like this. Okay. So this can be generated with these things, right? Okay. So let's end up here. So this can be just replaced by these things. Now you can apply is like, let's see, you write it as an array, and you can say that you are taking some numbers 10, 20, 30, and you can write the d type as the np, instead of np, write it as I4, I2. So you can define it like this. So if you see your dt, it will say that it is an integer of 16 bytes. Okay. So these are the common things that you can just have on. Okay. So very common things. So B stands for boolean, I stands for integer, U stands for unassigned integer, and all these things. Right. So I will give you these kind of things. Okay. Now data type is clear to everyone, I hope. Okay. Let's move to the next topic, that is your shape. So shape of an ND array. Okay. So this will return you a tuple consisting of array dimensions. If say, then this will return you a tuple consisting of ND dimensions. Okay. So yeah. So let's see how to find a shape of an array. So let's say we know basically the dimensions. What are dimensions? How we can find on dimensions? How you can set the minimum number of dimensions? Or you can just check on for the data types and how we can set those things, right? So let's see about how we can just check on the shape of a particular array. So let's say that this is array 6. Let's say we have these things. Okay. So this is my array. If I print the A6, I'll be getting the values, that is 1 2 3 4 5 6. This is my array. Now I want to check my array shape, so it's a dot shape a6 dot shape. This will give that 2 comma 3. This states that you are having 2 rows and the 3 columns. Okay, so you are having these as your rows, 1 4 2 5 3 6 as your columns, and 4 5 6 1 2 3 as your rows. So you have 2 rows and you have 3 columns. Understood? This is your shape defined as. Now let's say if you write, if you want to see a shape, you can find it's 1 3 3. So why it's 1 3 3? If I just print it, so only if I just print it, there is some problem. Yeah, sorry. So if we just run this, so we can get it 1 2 3 4 5 6 7 8 9. So why is 1 3 and 3? So it says that this is a single array, particularly stored in one particular thing. So you can see that these are just stored in one single bracket. Okay, so that is just stored in the one single bracket. Okay, so it says that there is one bracket. Okay, there are 3 columns, 1 rows, you can name it all. So one row particularly, here see what happened, here you are having your 2 rows kind of thing, you can see. So it is particularly 3 rows 3 columns. Okay, you can check it. Meanwhile, you can just insert or delete any of the things, then you can find it an array of that is an object. Sorry, so that is an object. So you can also check the shape of that. Sure, it's now 1 and 3, 1 row 3 columns, that's it. Alright, so but in this case it says that 1 rows 3 columns and each is having 3 of each 3 of the elements you can see. Okay, good. Okay, good. Okay, he's saying for that. Good. Okay. So this is how you can just make or you can just check on the shape of things, right? Now if you want to reshape something, if you want to just reshape your data, how will reshape? Now let's say that I am having an array. So I am reshaping my array. So reshaping array can be used with the method of reshape. Let's say any kind. Let's say you have A7, an array. Yes. Yes, Harita, say. Yeah, your voice is not clear. Cell number, you are saying some cell number. 29? Yes, you're asking for the cell number 29?
Yes.
Okay. So this is particularly saying that we are having one of the array, okay, one array, or you can say as one row. Particularly there you are having 3 elements, 1, 2, 3, right? And in those 3 elements you are having more 3 kinds, 1, 2 and 3. Understood?
Yes.
Alright. So reshaping of an array. So let's say this is an array and these are 10, 11 and 12. Okay, I'm not defining data type and any of the things. This is just a normal and array I'm having. Okay, so I'll print down the A7, and I will also print the A7 shape. So this is an array of 10, 11, 12, and also I'll be printing the A dot. So this is, you can see that this is an A7 array of 10, 11, 12. Your shape is 3 comma nothing. Let's say that you have 3 elements and no columns. Okay, no columns are there, only 3 elements are there, that's all. No, nothing has been defined on. And you are having 1 as your dimension shape. Okay, so now we want to reshape something. So we can see the shape as this. Now let's say that I am reshaping this. Let's say I write something here more. And now let's check. So this is my array. This is my 2 by 3, that is 2 rows 3 columns as my shape, and 2 is the number of dimension I'm having. Okay, so what I can do is I can reshape it now. So let's print it kind of reshaping into 3 rows and 2 columns. So from the 2 rows and 3 columns, I'll reshape into 3 rows and 2 columns. So you only need to do dot, that is A7 dot reshape, and that's all you have to do. So reshape it by, and you write the shape, that is 3 by 2 you want. That's all you want this. Okay, and then you can just print on. Let's say you want to store this in an A8. So A8 is equals to A7 reshape by 3 by 2, and then you can just go on printing A8. You can check for the A8 dot shape. You can check for A8 dot size, not size. First, just see the number of dimensions. So that's all. So when we'll print this, we'll see that reshaping into 3 rows, and it is now from the 10, 11, 12, 13, 14, 15, it has become 10, 11, 12, 13, 14, 15. The number of shape is, so the kind of shape is 3 by 2. So this is the shape I'm having, and the rows or the number of dimensions, this is as the 2. Got it? So this is of the function of the reshape. You can just reshape on things, right? The reshape can also be used to make something as a linear. Linear, I mean to say that, let's say you are having A8 as a 3 row. So this is very important term. Many times it comes in the interview questions also, that if you write it as reshape of -1 will break down any n-dimensional to one-dimensional array. That is very much important. So a reshape of -1 will break down any n-dimensional array to one-dimensional array. How? Let's see. So this is a 2-dimension figure, right? This is a 2-dimension figure, I can see there. 2-dimension figure. Let's do that. A9 is equals to A8 dot reshape -1. Print your A9, print your A9 dot shape, print your A9 dot dimensions. So you can see this is 10, 11, 12, 13, 14 and 15. And the number, this shape is 6 and nothing else. Okay, as you see in the one dimension, and your dimensions is 1. So there are several methods to make any n-dimension array into a single dimension. So we'll learn one by one. But before that, learn this that uh, for making or breaking anything to a single dimension with the help of reshape will give you kind of uh, in the reshape minus 1. That's all. Okay, so you can get it by that. Now let's say, hold for a minute. Okay, so this is, you can get it on in the reshape one. Similarly, let's see to the next things. The number of dimension can be used to find the dimension of an array. So what if I want to define a zero dimensional array? So for a zero dimensional array, there the basic thing what I say to you that if you have a number of brackets in your array, the number of brackets will define you the number of dimensions in your array. So what if I don't define any kind of brackets? That will give me a zero dimensional array. So if I write it as if I just take over the things and if I just write it as go m, so if I write it as the zero dimensional array. So zero dimensional array could be np dot array any numbers 12. Okay, so this should be a zero dimensional array. So if we check on the zero, if we print on the zero, but if we print on the zero dot the shape, these things, so you'll get that endem is not defined. It is not having any number of dimensions. You can write it as 0 dot endem, then you'll get something there, but still it is not having any dimensions. You will get that 0. Okay, so let's run this. So you can see that it is not having any kind of shape, that is an empty area. It is having a dimension that is 0, and you can see the printing of the 0 is nothing but the 12. So what happens that many a time you will get some of the questions as the outputs. So you will be given an output like this, and you will be asked to print this with the use of Numpy, Numpy. Right? So in that case, what you can just measure of the things that you have been asked just to print an array. So these are the things which you should focus and just keep store in your mind, like in the year, just whenever you see it, okay, you understand that okay, first we have to print a zero dimension array, and then the shape and then the dimensions. So many a times it is asked like this output. So you will get some of the outputs like this. Maybe it can be just replaced. So might be the brackets come first or the values come. Okay. But any of these three things, when you get and when you ask with the use of Numpy, that's exactly a zero dimensional array. Okay. Moving on. So this can be a zero dimensional array. Okay. Yeah. So now let's say when we work on the range things, right? When we work on the range things, in the morning I have discussed with the students that in case when we want to generate the OTP, and we don't want it to be common, right? When we generate, because generating OTP is not a big deal. Okay, that can be anyone can do, but just to think over it, and then anyone can do that, right? So generating OTP is not a big deal, right? But making it not common is a big the small factor. Okay. So yes, now can anyone tell me if I make some OTP, what are the chances that I can get common values? Number of chances that I can get the common values. Any probability from your side? You can say any percentage, right? I also don't know what are the chances to get a common because that can be a random one. Random, you can't predict it exactly the same, right? So just write your uh, answers here. What are the probability you are thinking that you will be getting a just a random value? Yes. Okay, no one is saying anything. All right. See, most of the time chances are like 20%, 3%. Depends on the situations. Depend on the ranges you leave. Okay. So let's say that I have imported random. Let's say we are importing random. Let's say random is there, right? So from Numpy I have imported the random, and now I'm writing the random dot. Now I'll be taking the random integer. So I'm taking random integer, right? So I define 122,890. Let's say any values. Okay, I have defined some digits and getting a random number there. So what is the probability if I run this particular thing? What is the probability I'll be getting the same numbers? What is that probability? How will I get the same numbers? Or how to avoid the numbers coming same? Let's say I have taken a list over there and I have said that for the x in range of 20. For x in a range of 20 numbers, what you do, you say r is equals to this particular statement. And you do one thing that you keep on appending, let's say it's I. Let's say you keep on appending the value of x to the I. Oh, sorry, the value of I to the x. Sorry, it's x to r. Okay. So for I in a range of 20, I'll be getting a random number and I'll be appending it to the x. That's all. Right. It's a very simple program. And after these executions, what I'll do is I'll just print on my x. So let's see, these are my numbers. Okay. So there's are my numbers. So any numbers in things common there, anything is common there in the between the 20 numbers, anything common. So how to get the common numbers now? How will I see if anything is common there or not? Yes. What I can do is, since it's a random one, so it's not sorted. So what I'll do is, let's make this a sort one. So every time I don't need to make it sort at the last. Every time I'll just sort it there automatically. Now x will be x dot sort every times. None type has no. Oh, sorry. So this is my x. Let's see if anything is common. So here nothing is common. Let's make it to 200. There might be some common things. So you can see the output coming here as very fast, right? So is there anything common? Can you guys see it? Let me zoom out. So how to find the common things? How to find it from here? So here we'll be using a method called as unique. That is unique. I'll say unique of this x So these are the unique numbers. So let's first calculate the length of x and then print the unique, and then let's see the length of this np dot unique functions. So that's correct. No copied value, or you can say none of the duplications value. Let's make this as some thousand numbers. Let's make it for 1,000. So this is a problem. When you give these range, this will happen as a this will go for a long processing time. Okay. That will take a long time to process it. Run this, it will take a long time to process. But instead of this, if you write a Numpy array, I'll compare these things. I'll compare the Numpy array versus list, and when you will see how it works out. So instead of this, if you have given it as a kind of a Numpy array, so that would have done this thing in a very convenient, very short time. Okay. How? Let's see. Instead of this, if I would have written that if I would have written that this is a list, right? So for in a range of np dot arrange, go with these things, append there and submit. So this will take probably very less time as compared to the list. Let's do some of the listings. It's taking still the times. Stop this. So this is your x, particularly not printing now, or let's say we print x of only some 50. That can be good. So x of 50 is this. So these are the first 50 numbers I'm getting, right? Now let's see the unique numbers and let's see if any duplications are there. Yeah. So we saw that we are having 1000 numbers and there are only 996 unique numbers. Or we can say that we have only 996 itself the same, the different values, or 996 different numbers. And the rest of the 4 numbers where that 4 could be the same numbers. Alright? So those 4 could be the same ones. So how to get that 4 ones? What you will see that it's np dot unique. I'll let you know for the more of the kind of the unique functionalities. So here we'll go to find the unique one. So this np dot unique, if I say x and I say that go with the index count. Numpy has no module of unique. This problem I faced in the morning too. So let me just come with the question here. It says written Python training ED8. In the morning we did the same thing, but they don't know about the Numpy, right? So I discussed them that how to make a thing. Today we were learning about the list. So we made that. We saw it like that. Where it has been. So we generated some of the OTPs in the morning today. So a lot of OTPs there, and with an Numpy, so these were the 100 OTP we generated. Yes, this was. So this will return me the counts. So length of np unique is x and the return the count is nothing but the two numbers are common, right? So two numbers are common, that is, it make four. If I say that I want the index for it, so if I just write on the things, let's say where it has been, okay, just take it as if I write. So the number of returnings you are getting is, so unique of x will give you np dot unique, this unique of x will give you the numbers, right? So let's take it for 20. So this will give you an array out there if you don't define anything. So you're probably getting everything there. So this is my 1000 numbers, that's correct, that's okay. So I want to be the same numbers, right? I want the duplication values. So for duplicating, you're passing on the x and you'll be saying the return comes to be any counts returning? No. Okay. So why it's not giving us parameters are not coming. Okay. Let's if I write that as counts are not coming. There are four numbers replicating. So these are not just, and it's probability not good to just count on for one by one. So let's see the indices of these arrays. If that is, let's see the indices, we'll get to that. Yeah. So numbers up to 995 are common. After then there has been a replication. That is correct. So these are the numbers you are getting there, or you can just click on for the A of indices. So it will give the values, and these are your common values. And after then the number has been duplicated. You can say you have got some of the index, right? That's good. Okay, so unique will be just used for returning the coming elements or the unique elements, you can say. So how to avoid this duplications? So for duplications, for avoiding these things, what I done is we did term called as, we did in the assignments. There was an assignments, untitled. So we did a small program there. It is from random, import the random. We took over the x as a list, and we took over just a range that is from 1 to 100. And what we did is we just taken the RA as the random numbers, what I'm getting, and in the x we did the continue. Okay, we did the continue there. So if I copy this thing and I run it here, this is our one. So we have random, so not taking it here. So random we have now, it's random dot random. So random dot random of some numbers, and you can take as a range of np dot range 1001 random numbers between these things and append this to the a. Let's run this down. So if we come to see the sum of the numbers, that is from the 30. So these are the random values. Okay. So when you come to see, so you want np dot a range of some 1000 numbers, and you are giving a very less range of 1 to 100. So when you print your x, you will be getting only these values in place of 1000. Okay, you have given 1000 number range, but you will not be getting 1000 numbers. Why? Because you have said that you will not be doing any duplications. So you will be getting only these numbers, right? So you can give these values. So instead of getting 1000, if I would have written as 1 lakh or 1 crore or 1 million, anything, right? Still we would have get only these values because we don't want any of the duplication. So what we did is a very common thing, that if these lies in the x, if the following, let it be a blank one. Okay, then what we did, that if the random number lies in the x, then continue that. That is, skip that one. If it not lies, then append it in the array. It's a very common thing, right? So we did the very basic thing. So as again I say that use basic concepts. Okay, that is necessary. So you can print the sorted list and sort, and this is your sorted. Okay, that's good. X dot sort comma x, and this is your x values. So let's bring up to 10 values. This is your x dot sort and your x values. Okay, the basic thing, right? Moving ahead. So for getting a range of numbers in Numpy, you will be using, let me write it as, if you write it as for getting, let's say, making a range in Numpy, we use np dot arrange. The common thing we use is the np dot arrange there. Okay, this is the basic thing we use in the Numpy. Okay, this is a very basic factor we use. Very basic things. Okay, let's go with that. So run this, and okay. So let's say you're making a 7A, it has been given. Yeah, so let's A9 is equals to np dot array, sorry, 1 2 3 4, right? These are 1 2 and 3 4, very, very similar. So this isn't just a common thing how you can make an array, right? But instead of making these things, you want to make an array of single dimension or double dimension you want. Okay. So how can you make that? So let's say A10. So you want some 3 rows, or you want 100, a range of some 100 numbers. And the size you want this like 5 by 2. Why? Whoa, that is long. We declare size. Might be changed, no problem. Let's just take it off as 9. If it is not working like that, I'm using a 3 by 2, that's it. So cannot reshape a size of 100. Oh yeah, sorry. Can just write it by 5 by 2. Can be a multiple of that. Let's say 5 by 20. 20 columns will be enough. Let's say 10 by 5 or 10 by 10. So A10 could be an array having the numbers of 1, 2, 3. This can be work as an arrangement. So we'll be using one by one these things. Okay. Let's move it again now. So arrange can be work as like that, okay, and you can give your number of dimensions. You can reshape it, and anytime you want, you can just reshape it, right? So this can be done. Moving ahead. Now, this is item size. So this will return you the length of the each elements in an array, and that too in the bytes, right? So this will return you like that. So let's say we're taking as A10. Give some numbers. These are my array, and let me just print the item size. So I'll see that this is an array, and the item size I'm getting is that 8. Okay, so each element is having an 8 bytes of item space. So that depends on the data type, right? If you print your A11, let's see what the data type is. If you see your data type, it will say that It is of integer 64. So integer 64 is having each of the 8 bytes. When you define anything, let's say when you define this as your A11, so when you define your data type, let's say you are defining your data type to be 98. So you're defining your 98. So when you check this now, when you check the data type of this, or when you check the item size of these things, so you'll be getting an item size that is 1. So if in any array the items are of 8 bytes of integer, so you'll be having every item size as 1. So it depends on the data type. So this is particularly, so let me print it. So this is having a data type of integer 64, and this so this is having an every elements as 8. Okay, that's cool. Moving ahead. So you can give your float size and any of the thing else, right? You can give this particular as a float one also.
So,
Yes.
this item size we as I tried it, I got this.
Harita is speaking. Yes, Harita, your voice is again not clear.
For the item size, I got this instead of 8. Is that okay?
You are writing, I'm able to hear that item size, you are writing something instead of
Wait,
something.
I'll type it.
Okay, yeah, you type there, I'll see it. Might be some technical issues. How many are there? Okay. I'm getting the item size as 4 instead of 8. Is that okay? So you do one thing, you type your array name and then check for the type. You type like that, array name dot data type, and you see what is coming there. See what's coming. What is the data type? Write your array name and check for the data type. Integer of 32. So integer of 32 is having some 8 bytes of 4 byte of space. Okay, no issues with that. That's fine. Yes, let's carry on. Where is the charger? Yes. So item size is that. Moving ahead. So there are something as called as your flags. Okay. So this ND object has the very following attributes. I'll be working with that own data and all these things. Okay. So that will give you a flag. Okay. So what are flags particularly? Okay. Flags are not very much important. We'll discuss on later that. Okay. Because it's not related to your course also. Let's say these things. Let's study about the topic of np dot empty. Okay, so this will create it creates an uninitialized array of specified shape and data type, and it uses some of the constructor methods. I'll be discussing it what it uses. So here it came as np.empty, and it uses shape. It uses a data type which can be float. It uses an order which is C. Okay, so there is these are the parameters you are having. Let's make it as a it uses these things. Alright. So shape of an empty array in integer or tuple of an int. Okay, shape is the shape of an empty array that is given. Now D type is the data type, desired data type, that is an option. And order is C, is the style of row measure array. F stands for Fortran and C for the these things, right? So that is coming in the flags of order or all these things, right? So let's write it there and you'll make it to understand. So let's say this is an empty one, 3 by 2, and the data type I'm giving is integer of 32. It's nice. Int of 32 is not defined. So there it is. Okay. So let's print it that what is A12. So this is 10 0, 11 0, 12 0. So what do you have got that? 3 by 2, 10 0, 11 0, and 12 0. And why that? You have given some 3 by 2 and you got some of the values. What if you give 5 by 2? So you got 0 0 0 0 0 and everything there. Why? That's a concept behind there. That is some of the concepts there. So this give you some of the elements and give you some of the random values which are not initialized, which you don't give anything. It comes automatically every time a new one or can be anything there. It can come anything. You don't initialize there it as a random or something. It comes as a random one of any kind. It can be integer, it can be float, or any kind it will be coming there. Okay. So these are not much used very much in the industries. Okay. So these can be defined as there can be any random values, but zero would be there. Okay. That is an empty statement. Okay. It's not a very good thing to work on. It's not for your use. Okay. It will not give you anything there. So for using a zero matrix, if you want just to print a zero, so what you do is you will use the basic things. What? Like for the np dot zeros. So this will return a new array of specified size filled with zeros. Now it can have, let's say if you are writing an element of 5 zeros, you are writing just a zero matrix, right? You know zeros, what you might have studied in class 11th or in the matrix section. So you write zeros of 10, and the first chapter of class 12, I think matrix is that. So np zeros of 10, so you're getting the zero there, right? So depends if you give your shape also. Let's say you can write it as, let's say, zeros of 10, and you have given it as a data type to be an integer instead of the float. You want it to be an integer, right? So that will be given there. Okay. And you want it to be reshaped into 2 cross 5. What is the problem? Data type is the problem. D type equals to np.int. Now it's done. I hope it's done now. D type is still a problem. Or sorry, there is one more comma. So you can find on that this is a 0 of 10 numbers having reshaped into 2 rows and 5 columns, and the data type is kind of an integer. Similarly, you can go with the np.ones. So this returns a new array of specified size and the type filled with ones. Okay, these are kind. np.ones. So here you have np.ones and you write your array, or sorry, not array, you write your shape, you write your data type to be your one. By default it's none. And that is, you just define these things to be there. Okay, how you do in the 0 1. So let's say it's ones, I'm making a ones of 10. So this is a ones of 10. Instead of 0 you will be getting ones. Similarly, if I write ones of 10 and the data type I'll be giving integer, and let's say I want to reshape this to 2 plus 5. So this is 5 cross 2 and the data type you are getting in the ones, you can say on, right? These are the uses. Similarly, with the help of this you can make an I also, right? So today we'll learn till the I1. Okay, so the last is the I. This will return you a new array of specified shape with identity matrix. Okay, so you'll be getting at that. And for that, you'll be writing it as an I. You pass on your values, let's say 5. So you'll be getting an identity matrix of 5 by 5. Okay, you pass your I and you write your 5 as the D type. So getting as an integer 35. Or for more info if you want, so for any operation if you want any info from the Numpy, you will be writing np.info and then pass out the parameter you want. So if you want the information of ones, just pass on the ones. It will say that it is having ones, shape and these things. So return a new array of the given shape with the filled ones. Shape is nothing but these things, order and all the functions you'll be getting. Full is return a new array of given shape with some values will be giving. Empty will have some uninitialized array, as I said, right? So ones of 5 will give you this, ones of 5 comma this will give you like that, and ones of this will get that, and so on, right? So these are the things you will having on. So today till here we'll learn NumPy greater more from tomorrow.